1100 AD, Europe is using Roman numerals. Addition requires an abacus. Multiplication is nearly impossible. There's no concept of zero in most of European mathematics. Scholars are still arguing about whether numbers even exist or if they're just philosophical abstracts. That same year, in what's now Nigeria, Yoruba mathematicians are using a complete binary system, a mathematical framework based on base 2 calculation. Ones and zeros, on and off, yes and no. The same foundational logic that powers every computer you've ever used, every smartphone, every digital device, every line of code. They're using it for divination, yes, but also for complex probability calculations, pattern recognition, and information storage. 256 possible combinations, organized into a systematic mathematical structure. European mathematicians won't develop anything comparable until 1679, when Gottfried Wilhelm Leibniz invents binary code and gets credited as the father of computer science. 700 years later, modern scholars will discover the West African system. They will analyze the mathematics, document the sophistication, trace the possible transmission routes to Europe, and they will publish in academic journals that almost no one will read. Because if Africans invented binary mathematics 700 years before Europe, then everything you were taught about the history of mathematics, computer science, and human intellectual development is built on erasure. So let me show you how this system worked, why it's mathematically identical to modern binary, and how they made sure you never learned about it. Let's start with what you were taught. The history of binary code, the foundation of the digital age, the mathematics that changed everything. It goes like this. Gottfried Wilhelm Leibniz, German mathematician and philosopher, 1679. He develops binary arithmetic, a number system using only 2 digits, 0 and 1. He writes about it in his paper, Explication de l'arithmétique binaire. He's celebrated as a genius, a pioneer, the father of binary mathematics, and binary becomes the foundation of computer science. Boolean algebra builds on it in the 1800s. Electronic computers in the 1900s use it as their core logic. Digital technology runs on it. Every computer program you've ever used, every website you've visited, every app on your phone, all of it traces back to Leibniz's binary system in 1679. That's the official story. Leibniz invented it. Europe gave it to the world. The digital age is a European achievement. Here's what they don't tell you. Leibniz didn't invent binary mathematics. He encountered it, and he encountered it through exposure to an African system that had been operating for at least 600 years before he was born. The Ifa divination system, used by the Yoruba people of West Africa, present-day Nigeria, Benin, Togo, but also spreading across the African diaspora through the transatlantic slave trade to Cuba, Brazil, Haiti, Trinidad, throughout the Caribbean and Americas. You were probably taught it's a religious system, spiritual divination, fortune-telling, and yes, it's used for divination. But here's what they didn't tell you. It's also a mathematical system, a complete binary mathematical framework. Let me show you how it works. The Babalawo, the Ifa priest. The diviner uses palm nuts or a divining chain. When they cast, they're generating a random binary outcome. Each throw produces either 1 mark or 2 marks, 1 or 2, on or off, yes or no, binary. They cast 8 times. Each cast produces a binary digit. 8 binary digits create 1 figure. In Ifa, these are called Odu, and there are 256 possible Odu. Let me stop there for a moment. 256 possible combinations. That's 2 to the 8th power. That's base 2 mathematics. That's binary code. Each Odu is a unique 8-bit binary pattern, just like a byte in computer science. 8 positions. Each position can be one of 2 values, 256 total possibilities. The Yoruba organized all 256 Odu into a systematic structure, gave each one a name, memorized the meanings, the stories, the interpretations associated with each pattern. They weren't just doing divination, they were performing complex pattern recognition using binary mathematics, and they were doing it in 1100 AD. Leibniz won't publish his binary system until 1679. That's 579 years later. But let me show you why this isn't just similar to binary. It is binary, mathematically identical. In modern binary code, you have 8-bit bytes. Each bit is either 0 or 1. The IFA system has 8 positions. Each position is either single or double. In binary, you can represent any number from 0 to 255 using 8 bits. In IFA, you can represent any of the 256 Odu using 8 casts. The structure is identical. The logic is identical. The mathematics is identical. Here's where it gets even more specific. The IFA system organizes the 256 Odu hierarchically. There are 16 major Odu, the primary patterns, and 240 minor Odu, combinations and variations. The major Odu are organized in pairs. Each pair represents an inverse relationship. This is binary logic, on/off, positive/negative, complementary opposites. The Babalawo had to memorize all 256 patterns, all the relationships between them, all the mathematical transformations. They trained for years, decades sometimes, because this wasn't simple memorization. This was understanding a complete mathematical system, the relationships between Odu, the transformations, the patterns within patterns. And here's what makes it undeniable. When you map the IFA Odu onto a binary grid, they align perfectly. Computer scientists have done this. Mathematicians have done this. You can take the 256 Odu and convert them directly into 8-bit binary sequences, one-to-one correspondence. No adaptation needed, no approximation, direct conversion, because it's the same system. Let that sink in. African mathematicians were using binary code, actual, functional, sophisticated binary mathematics, 700 years before Leibniz. If you're realizing that everything you learned about the history of mathematics just collapsed, stay close, because we're about to show you how Europe encountered this system and how they made sure the credit went to a European man. So how did Leibniz encounter it? This is where the historical record gets deliberately murky. But we have evidence, fragments, traces. 1697, 18 years after Leibniz publishes his binary system. He's corresponding with a French Jesuit priest named Joachim Bouvet. Bouvet is in China. He's studying the I Ching, the ancient Chinese divination system. And Bouvet writes to Leibniz, "Your binary system is remarkably similar to the I Ching." The I Ching also uses binary logic, broken and unbroken lines. 6 lines creating 64 hexagrams. It's a binary system, like IFA. Leibniz is fascinated. He studies it. He writes about the connection. But here's what the history books don't emphasize. The I Ching wasn't Leibniz's first exposure to binary divination. By the late 1600s, European scholars had been encountering African divination systems for decades. Portuguese traders and missionaries had been in West Africa since the 1400s. They documented IFA divination, described the casting systems, noted the patterns. Dutch merchants, Leibniz's own countrymen, had established trade posts in West Africa by the 1600s. Descriptions of African divination systems were circulating in European intellectual circles, and Leibniz was a scholar, a voracious reader, a collector of information from across the world. He was reading reports from Africa, from Asia, from the Americas. He was synthesizing knowledge from everywhere he could find it. Did he directly copy the IFA system? We don't have a document where he says, "I learned binary from Yoruba mathematicians." But we have this. Leibniz develops binary in the 1670s, exactly when reports from West Africa about divination systems are reaching European scholars. His binary system is structurally identical to systems that had existed in Africa for centuries, and he never claims to have invented binary from scratch. He frames it as discovering a principle that already existed. The question isn't whether Leibniz invented something entirely new. The question is, where did the principle come from? And the evidence points to Africa. But let's say you're skeptical. Let's say you think this is coincidence, parallel invention, independent development. Fine. Then explain this. The geomancy systems of West Africa, which are related to IFA, spread across North Africa and into medieval Europe. By the 1200s, European scholars are practicing geomancy. They call it by its Arabic name, Ilm al-Ramal. It uses a system of generating random marks, organizing them into figures, interpreting patterns. Sound familiar? It's binary logic, and it came from Africa. Ramon Llull, the Catalan philosopher, develops a mechanical device in the 1200s called the Ars Magna. It uses combinations of symbols to generate logical conclusions. Binary style thinking. Where did he get the idea? He was in North Africa. He studied Arabic texts. He encountered African knowledge systems. The evidence of African binary mathematics reaching Europe isn't hidden. It's just ignored. Because if European scholars admit they encountered binary logic in African systems, then Leibniz can't be the inventor. He becomes the systematizer, the formalizer, the European who wrote it down in European mathematical notation, but not the originator. And the entire story of European mathematical supremacy gets complicated. So let me show you the timeline, because this is where the erasure becomes undeniable. 1100 AD or earlier, oral traditions suggest the system is much older. Ifa divination system operating in Yoruba culture. 256 ODU, complete binary framework. 1100 AD Europe using Roman numerals. No zero, no place value system. Mathematics is rudimentary. 1200s. African geomancy systems spreading to Europe through North Africa and Arabic scholars. 12th century, Ramon Llull develops combinatorial logic systems after exposure to African knowledge. 14th to 16th centuries, Portuguese, Dutch, French, British traders, and missionaries documenting African divination in West Africa. 1670s, Leibniz develops binary arithmetic in Germany. 1679, Leibniz publishes Explication de l'arithmétique binaire. He gets credit as the inventor. 1697, Leibniz corresponds with Bouvet about I Ching binary similarities. 1854, George Boole develops Boolean algebra based on binary logic. He builds on Leibniz's work. Leibniz is cited as the foundation, no mention of African systems. 1937, Claude Shannon shows that Boolean algebra can be used in electronic circuits. Binary becomes the foundation of computer science. All credit traces back to Leibniz. No mention of African origins. 1946, first electronic computer, ENIAC, built using binary logic. The digital age begins. The story is, European mathematics made this possible. No mention that the foundational logic existed in Africa 800 plus years earlier. Let me make sure you understand what just happened. For 800 years, the Yoruba had a functioning binary system. For 800 years, they trained mathematicians to memorize and manipulate 256 binary patterns. For 800 years, they used this system for probability calculations, pattern recognition, and information organization. Europe encounters it, adapts it, formalizes it, and takes all the credit. the African origin is erased, and the narrative becomes, Europe invented binary. Europe created computer science. Europe gave the digital age to the world. A lie built on erasure. Now you're probably thinking, but Leibniz formalized it. He made it mathematical. He wrote it in notation that could be used for calculation. That's true. But here's what you're missing. The Yoruba already had formal mathematical training for the Ifa system. Babalawos studied for 20, 30, sometimes 40 years. They had to memorize all 256 Odu, all the transformation rules, all the relationships between patterns. They had to be able to calculate probabilities, to recognize patterns instantly, to manipulate the system fluently. This wasn't informal knowledge. This was rigorous mathematical training, and it produced mathematicians who could perform complex operations that European scholars couldn't. Let me give you an example. Each ODU has associated stories, proverbs, meanings, and divination interpretations. But more than that, each Odu has mathematical relationships with other Odu. Transformations, inversions, combinations. A Babalawo could look at one Odu and instantly know its inverse, its complement, its related patterns. They could perform what we'd now call Boolean operations or not XOR, binary logic operations, without writing anything down. Pure mental calculation using a memorized binary system. And they'd been doing this since at least 1100 AD, probably earlier. The oral traditions suggest the system is ancient. So when you say Leibniz formalized binary, what you mean is he wrote down in European notation what Africans had been doing mentally for centuries. That's not invention, that's translation. And translation doesn't make you the inventor. Here's what was lost, not just credit. Though that matters. We lost the recognition of African mathematical achievement. We lost the understanding that binary logic is a human universal, that multiple cultures developed it independently. We lost the knowledge that African mathematical systems were sophisticated, rigorous, and functional. But more than that, we lost the actual mathematical knowledge embedded in the Ifa system. Because Ifa wasn't just binary, it was binary plus context. Each Odu wasn't just a number, it was a number with meaning, with associated knowledge, with layers of interpretation. The Ifa corpus, the complete body of knowledge associated with the 256 Odu, contains thousands of verses, stories, proverbs, historical accounts, medicinal knowledge, ethical teachings, all organized according to binary patterns. This is information architecture. This is what we now call a database structure. Binary codes linked to semantic content, a knowledge organization system, and it worked. For centuries, the Ifa system preserved and transmitted vast amounts of cultural knowledge across generations, without writing, without books, just through binary patterns and associated oral traditions. When colonization arrived, this system was dismissed as superstition. Missionaries called it witchcraft. Colonial authorities banned it in some regions. The knowledge transmission was disrupted. Young people were sent to Western schools where they learned that real mathematics came from Europe. That binary code was invented by Leibniz, that Africans had no mathematical tradition, and the Ifa system was reduced to folklore, cultural heritage, religious practice, where its mathematical sophistication was ignored, erased, forgotten. Generations of African students learned computer science and were never told that their ancestors had used binary mathematics for centuries. They studied Leibniz and Boole and Shannon, and never learned that the logic underlying all of computer science existed in Yoruba mathematics 700 years earlier. That's not just historical erasure, that's theft of intellectual heritage. But here's what they couldn't erase: the system itself. Ifa survived. Through the transatlantic slave trade, The Yoruba brought Ifa to the Americas. In Cuba, it became Santeria Divination. In Brazil, Candomblé. In Haiti, it merged with other African systems. The binary structure remained intact. The 256 ODU, the casting method, the mathematical logic. Even when the cultural context changed, the mathematics survived. And in the late 20th century, scholars started paying attention, not just anthropologists interested in religion, mathematicians, computer scientists, information theorists. 1980s to 1990s, researchers begin analyzing the mathematical structure of Ifa. They map it onto binary grids. They study the information theory. They recognize the sophistication. Ron Eglash, American mathematician and cyberneticist, publishes African Fractals in 1999. He documents mathematical sophistication across African cultures, including the binary structure of Ifa. He shows that African mathematical systems weren't primitive. They were different, but equally sophisticated. And specifically, he demonstrates that Ifa is mathematically equivalent to binary code. Not similar, equivalent. Sophie Oluwole, Nigerian philosopher, writes extensively about Ifa as a knowledge system. She argues that Ifa should be recognized as philosophy and mathematics, not just religion. She documents the logical rigor, the systematic thinking, the intellectual tradition. More research follows. Papers in academic journals, mathematical analysis, historical investigation, and the conclusion is undeniable. The Yoruba were using binary mathematics centuries before Leibniz. The system is sophisticated, rigorous, and functional. And the connection to modern computer science is direct. But you still won't find this in textbooks. You won't learn about Ifa in computer science courses. When students study the history of binary, they learn about Leibniz, maybe Boole, maybe Shannon. Never the Yoruba. Because even now, even with the evidence published, verified, the undeniable, the narrative can't handle it. If Africans developed binary mathematics, then Europe didn't invent computer science. Europe formalized, industrialized, and digitized a logical system that already existed. And that distinction matters, because it changes the story of who contributes to human knowledge. It changes who gets credit, who gets recognition, who gets to be called innovative. And those questions threaten the entire narrative of Western intellectual supremacy. Let me show you how this erasure operates in real time. You can find academic papers on the mathematical structure of Ifa, published, peer-reviewed, verified, but they're in specialized journals, African studies, ethnomathematics, cultural anthropology, not in mainstream computer science journals, not in the history of mathematics textbooks, not in the curriculum. Why? Because acknowledging African binary mathematics would require rewriting the history of computer science. It would require admitting that the foundational logic came from Africa. It would require sharing credit, and institutions don't do that easily. The story of Leibniz as the inventor of binary is clean, simple, fits the narrative. European genius, European innovation, European gift to the world. The story of African binary mathematics is complicated. It challenges assumptions. It requires recognizing African intellectual achievement, so it stays in the margins, acknowledged by specialists, ignored by the mainstream, and students continue to learn that binary code is a European invention, that computer science has no African roots, that mathematics came from Greece and Europe and nowhere else. A lie. Perpetuated through selective teaching. Here's why this matters. It's not just about historical accuracy, though that's important. It's about who gets to be seen as innovative. When African students study computer science and learn that Leibniz invented binary, they're learning that innovation comes from Europe. when they're never told that their own ancestors used binary mathematics. They're being taught that Africa contributes nothing to science and technology. That's a wound, a psychological wound that affects how people see themselves, their heritage, their potential. And it's deliberate, because if African students knew that the Yoruba developed binary mathematics 700 years before Leibniz, if they knew that the foundational logic of every computer, every smartphone, every digital device traces back to African mathematical thinking, if they understood that African knowledge systems were sophisticated, rigorous, and globally influential, they would approach science and mathematics differently, with confidence, with pride, with the understanding that innovation is part of their heritage. And they would ask questions. What else did Africans invent that Europe took credit for? What other knowledge systems were erased? What other contributions were stolen? And those questions threaten the narrative. So the erasure continues, even now, even with the evidence published and verified. The history of binary remains. Leibniz, 1679. End of story. The African origins stay buried in academic footnotes, and the digital age is celebrated as a purely European achievement. If this is making you angry, good. That's the appropriate response, because we're about to show you exactly what this erasure means for modern technology. Think about every computer scientist who's been celebrated, every father of computing you've been taught about. Charles Babbage, Alan Turing, John von Neumann, Claude Shannon, all brilliant, all made real contributions, but all building on binary logic, a logical system that existed in Africa 700 plus years before Leibniz. Now think about every tech company, every innovation in Silicon Valley, every digital breakthrough, all running on binary, the foundational mathematics that powers the modern world. And Africa gets no credit, no recognition, no acknowledgement, no place in the origin story. That's not an accident. That's systemic erasure, and it has consequences. When the history of technology is told as a purely Western story, it justifies continued Western dominance. It suggests that innovation naturally comes from Europe and America, that Africa is a consumer of technology, not a creator, and that narrative affects everything. Investment decisions, where tech companies set up research centers, who gets funding, who gets opportunities. If Africa is seen as having no technological tradition, then African tech innovation is seen as imitation, not genuine contribution. But if the truth were taught, if students learned that binary mathematics has African roots, if the Yoruba contribution to computer science were acknowledged, if African mathematical systems were studied alongside European ones, then the narrative changes. Africa becomes a place of innovation, historical and contemporary. Now, African students see themselves as part of a technological tradition, not outside it. And the global tech industry has to reckon with a more complex, more accurate history. So let me tell you what the accurate history looks like. 1100 AD or earlier, Yoruba mathematicians develop and use the IFA system, 256 binary patterns, complete base 2 mathematical framework, used for divination, yes, but also for probability calculation, pattern recognition, and knowledge organization, transmitted through rigorous training. Babalawos memorizing all 256 Odu, learning the transformations, mastering the logic, 1200s to 1600s. Binary thinking spreads through African geomancy systems to North Africa and Europe. European scholars encounter it, study it, adapt it. 1679, Leibniz formalizes binary arithmetic in European mathematical notation. He publishes. He gets credit. The African origins are not mentioned. 1854, Boole develops Boolean algebra, building on Leibniz. Binary logic formalized for symbolic logic, no mention of African mathematical systems. 1937, Shannon applies Boolean algebra to electronic circuits. Binary becomes the foundation of digital computing. The origin story traces back to Leibniz. Africa is absent, 1946 to present. The digital age, computers, smartphones, the internet, artificial intelligence, all running on binary logic. The foundation laid by Yoruba mathematicians 900 plus years ago. Credit given entirely to European scholars. That's the real history. Not Leibniz inventing binary from scratch, but Leibniz formalizing a logical system that had existed in multiple forms across different cultures, including, and perhaps most sophisticatedly, in West Africa. And the erasure of that history isn't neutral. It's ideological. It maintains the fiction of European exceptionalism. It denies African intellectual achievement. It perpetuates the lie that Africa contributed nothing to human knowledge. This isn't just about one mathematical system. This isn't just about binary or IFA or the Yoruba. This is about the systematic erasure of African intellectual achievement. When you were taught that mathematics came from Greece and Europe, you weren't told about African mathematical traditions. When you learned that binary code was invented by Leibniz, you weren't told that Africans had used binary systems for centuries. When you studied the history of computer science, Africa was absent. Not because Africans weren't innovating, because the narrative required their erasure. The colonization of Africa, the enslavement of millions, the extraction of resources and knowledge for centuries. All of it needed justification, and that justification was, Africans are primitive. Africans have no civilization. Africans have no intellectual tradition. African binary mathematics destroys that justification completely. If Yoruba mathematicians were using sophisticated binary systems in 1100 AD, if they were training specialists to memorize and manipulate 256 patterns, if they were performing complex logical operations mentally, if their mathematical system influenced European thinking, then Africa wasn't primitive. Africa was innovative, and colonization wasn't bringing knowledge to Africa. It was extracting knowledge from Africa, taking credit for African innovations, and erasing the origins. They couldn't let you know that. So they buried the evidence, dismissed the scholarship, kept it out of textbooks. But the IFA system survived. The mathematics survived, and the truth is surfacing. In 1100 AD, Yoruba mathematicians were using a complete binary system, 256 patterns, 8-bit sequences, base 2 mathematics, the same logical structure that powers every computer in the modern world. Leibniz didn't publish his binary system until 1679. 579 years later, scholars have documented the African origins, analyzed the mathematics, shown the equivalence, published in peer-reviewed journals, verified, undeniable, and it's still not taught. Because if Africans invented binary mathematics 700 years before Europe, if the foundational logic of computer science has African roots, if the digital age is built on knowledge that originated in West Africa, then the entire narrative of European intellectual supremacy collapses, and the history of technology becomes what it actually is, not a story of European genius bringing light to the world, but a story of human innovation happening everywhere, including, especially in Africa, with European scholars sometimes formalizing, sometimes adapting, sometimes stealing that knowledge, and then taking all the credit. They couldn't let you know that, but the mathematics doesn't lie. The 256 ODU of IFA are mathematically identical to 8-bit binary sequences. The system is rigorous, sophisticated, and ancient, and now you know. This is the history they don't teach, but it's the history that needs to be told. If this changed how you see the history of mathematics and computer science, subscribe to this channel, because every week we're uncovering the innovations, the knowledge systems, and the intellectual achievements they tried to erase. Drop a comment. What other African contributions to mathematics and science do you think were deliberately buried? This is Ancient Africa Untold, and we're revealing the innovations they said never existed.
To astronomical observatories.